what we're going to do is like, I assume you already signed up. If you haven't signed up, you can use the QR code here to sign up. At any point, you can actually grab the food and grab some drinks, and you can like all enjoy the session. So, over to you.
Thank you, and feel free to heat up the food as well, because I know it's probably gone cold. So just grab a plate, put it in the microwave. Nothing worse than a cold sausage roll from experience. But yeah, as Harshana said, thank you for joining us. This is, I think, the second in-person meetup event this year, but we've had meetups ongoing for several years. They went online during COVID. Last year we came back to in person, which was fantastic. And really the meetup is just to bring, the aim of it is to bring us together as a community. And I know, we're not as big as the global or the wider Salesforce Trailblazer communities, but we do try and get together so we can talk and geek out on MuleSoft. So that's our common interest. And personally, with my background and what I do is I was a MuleSoft training advisor for a year last year, and now since the 1st of February, I've now joined the Trailhead Academy team, and I look after not just MuleSoft, but also any other Salesforce course that falls under our courses. We catalog. I think now we are going to introduce the first speaker, which is you, or?
Yes, it's actually just a couple of things to introduce.
Oh, sorry, introduction, sorry. So, although she's not here,
yes,
not coming, but we do have our great meetup leaders. Eva, which unfortunately she couldn't join us tonight. Krishna, who is here, put your hand up.
Hey everyone.
He is from Capgemini. Meetup leaders play a really important part in putting this all together. So thank you so much for helping to organise tonight. On to the next slide. Awesome, thank you. And of course, our amazing Salesforce Trailblazer guys. We have Harshana here tonight. Selena, she was just here but just had to leave. She had a prior engagement. But these guys, together with the meetup leaders, help to organise these events. So thank you very much. And yeah, I think we're meant to be co-hosting tonight. Myself and Krishna. All right, so this is our agenda. We have our community updates, which is going to be led by Harshana. Then we're going to pass it over to James. He is from Confluent. Sorry, I should say you'll say that as well, James Gollan. And then we're going to geek out on the unification of data products with Anypoint DataGraph with Harsh, and then I'll just give a really brief update on training and certification, followed by the very famous trivia, where you do get to win some swag. So let's begin with what's in meetups. I think I've kind of already taken you through that. So I'll just skip through that. I think the community announcements was back to you.
Yes, thank you very much. And before I begin, I wanted to thank the CloudWorks team for lending us the venue and sponsoring through the event, because the food and the things is actually from CloudWorks. So being part of the community is actually really important, because it's not just about us doing the of work or the Salesforce work. Coming here, meeting everyone who's part of the ecosystem. So it really helps to grow you as a person, grow your company as part of the ecosystem and the community, and to actually get to know each other and learn from each other. So yeah, thank you very much for our gracious host. So the first announcement. So the last time we actually had our session was 23rd of February, if I'm not mistaken. So it's been 6 months that we had an event last time. So there's been quite a lot of changes in the product suite. So usually I take 5 minutes, but I think I'm going to take 10 minutes today. So starting with the universal API management. So the first change I wanted to introduce is actually the API Experience Hub. We have been talking about the Yeah, universal API management, which is not a single product. It's actually part of like a larger ecosystem. You have multiple products. You have the API gateways. You have the developer portals. You have the developer experience layer, as well as the actual the layer for you to come and like interact with your APIs, which is the last part, which is the engagement layer. So we used to have a couple of products under that one. So we still have Exchange, which is the native part of the platform. And if you wanted to actually have like more like user-friendly or more fancier UI, what we used to offer is ACM or Anypoint Community Manager, which is based on the Experience Cloud from Salesforce. So what we have done and what we have realized along the way, for you to come up with the ACM product, you have to have quite a lot of technical experience to set up the Experience Cloud. So a lot of people did not like that experience, because if you are just a MuleSoft like a customer, but you are not a Salesforce customer, you don't have that capability in-house. So that means you have to bring in new people, you have to know how to manage all these platforms and things like that. So what we did from our product perspective is we went through that learning, we made it much easier for you to use. So what we did, we came up with a new product, which is still based on the Experience Cloud, but rather than you have to like start from scratch and you have to learn how to manage the Experience Cloud, you now actually follow more like a guided workflow. So you can actually spin up that instance pretty quickly. So early this year, what we did was we released that product. It's around June, if I'm not mistaken, June or July. So these are the new fancy UI that we have. So this is our northern outfitter, like a demo that we have. So you can see it, and you can actually use it, and you can actually even get access to this particular feature if you request through your customer success or your account executives. So, like I mentioned, it brings quite a lot of features into you. Like you can actually use that fast and easy guided UI to set up that particular platform. You can create your own branded portal for you to interact with your external partners or even for your internal stakeholders as well. So it's a new experience for you as a MuleSoft customer. But if you want, if you are already a customer of ACM, you kind of already know what you are getting with this product as well, because it's the same product behind the scenes. The second changes is actually the Flex Gateway, the API Manager, and then the API Governance, which are the other parts of the Universal API Management product suite. So we have released a couple of new versions of the Flex Gateway. The latest version is 1.5.1. There are new options for the deployment, additional policies. You can even do the conditional routing to multiple endpoints now with the latest changes. There are other updates like multiple upstream routes now supported through the Flex Gateway. And you will see that if you had been using Flex Gateway in your Kubernetes, you have to get through a little bit of hoops to get the liveness probe, because we did not provide a liveness probe which marks your health in your container or your pod early on. Now we provide that feature out of the box. So you don't have to muck around that container. You can actually use the containers feature out of the box. There are other features that's available in the roadmap. So these are some of those features. Some of that will come through this year. Some of that will actually come through the next year. Throughout this presentation, if you have any questions, let me know. And we actually have, sorry to point and put the spotlight on you, Andrew. So our CTO, Andrew, joining us. So he's kind of like across most of these features, the roadmap. So he can speak with you and tell some and share some of the details if you need to get that kind of details. So these are the updates about the Anypoint API Manager. And the API governance, we are releasing newer set of features in terms of the rule sets, some of the lifecycle changes as well. So these are the things that are already available and what's in the roadmap. In terms of the platform and the runtime, so we already released the Cloud Hub 2, so that's not new. but there are new capabilities available. So for example, if you had been using the Cloud App 2 for private spaces, we only supported HTTP and HTTPS as the protocols for ingress. But about a couple of weeks back, we actually released and GA'd the feature to allow you the TCP connections. So with that, you can now do HL7 and MLLP connections, which is for the HLS sector. So there are more and more protocol support coming throughout the year. So there will be more changes. So I was lucky to work with Chris, who's part of our team as well. So we're directly with the product on like TCP capability, because we have been working with customers, we get the feedback, and we have to take that feedback to the product, and they have been run through some of these changes and some of these POCs for the product. So we will actually work with more customers in the future to get those feedback, collect those feedback, we represent you within the product. So this is that new capability that you can see in the Cloud App. This is the changes to the exchange. So I'm not gonna spend more time on this one. Another new capability we released early this year or early last year was Runtime Fabric 2.0, which brought you the OpenShift support. The new capability that we added is actually the eCase Anywhere. So eCase Anywhere is actually allow you to run Kubernetes platform on your own infrastructure. So that means if you are an AWS customer, but you don't want to use AWS infrastructure, that you have your infrastructure, you can use eCase Anywhere packages to install on your infrastructure, but use AWS console to manage your infrastructure and the Kubernetes platform through the eCase Anywhere. So what we do, we provide a layer of RTF to run on top of that eCase Anywhere layer and provide that unification for the container orchestration for MuleSoft. So now going forward, what happens is if you want to deploy MuleSoft RTF on your on-premise deployments, you have two options rather than one. Previously, it was just about OpenShift, but now you can pick either OpenShift or eCase Anywhere. So that's the latest feature. So what's in the roadmap? We are going to support more and more CNCF-based Kubernetes distributions in the future. So that's in the roadmap. So you can see VMware, Tanzu, Rancher, and then some other things are on the roadmap. So those features will come along throughout this year and the next year as well. And the next interesting and long-awaited feature is actually Mule 4.5. So it's not available yet, but it's almost ready. So there are going to be some new features coming on top of that particular features, especially around data view. So there were some changes related to OpenTelemetry going into the release. I do not believe that will be available part of the GA, but on a later date, it will be available as part of 4.5 or 4.6. And the major changes into our own release timelines is actually we are adopting more Salesforce-oriented release cycle. So Salesforce has these 3 releases per year. We, MuleSoft, did not have that, but going forward, we will do the same. So every year, we are going to release 3 versions of MuleSoft, 3 edge releases, which means like a short-lived version. So it's going to bring in new features, and 1 long-term supported feature as well, or version as well. So that means if you want to get the latest and greatest features, you can jump onto that edge release, but it only has a limited runway. If you want to have long-term support, you have to go for a long-term version. So depending on your requirements, you can choose which version you want to do, and you can say, I don't want the latest and greatest right now. I'm happy to wait for another 6 months. So you can jump from the LTS to LTS. So that's the idea. We are going to release the Anypoint code builder pretty soon. So that has been on public beta for some time. So I assume you already have played around it. So this is the latest developer tool that we provide instead of the Anypoint Studio. So this is the next generation or the next evolution of our tool, developer tool. So we have been working on the web version, but so that's going to GA pretty soon, and we are going to release the public beta of the same tool for for your laptops and for your standard installations pretty soon as well. So
Today.
Is it today?
Yeah, I was really excited. For 15 For 15 years, I've had to been stuck with the clips, and today I got VS Code, so that was I just had to say something there because I was very
Is it
excited.
downloadable?
Yeah, I downloaded it today. I got someone distracted me, but I got it running on my machine, and there was one problem I saw, but yeah, I did download it, so maybe we can get the link to these guys. But that was big day. So yeah,
because people have been waiting for the pink for a long time.
Yeah, it is. Yeah. So personally, for me, it's an exciting day as well as a little bit of a sad day because I am coming from I am Eclipse committed. So
okay.
so I would have liked to the studio, but I do understand all the limitations and the problems that it has been having and not the user friendly.
Right?
That's fine. Actually, I like this code as well.
So from a tooling perspective, the VS Code extension, is it similar to the existing Anypoint Studio, or is it it's a different experience?
It's going to be slightly different, but in a good way. So if you see the studio, you will see it a little bit like a cloud close because mostly it's actually the limitations coming from the Eclipse as well as the hosting platform. Whereas with the VS Code, you have the lot of new features like interactions with the underlying features. So you're gonna have a better experience, I would say. So, I don't like saying, but yeah, here we have. And another thing that we're actually working on that I can't really share right now, but you will actually hear during the Dreamforce is actually, we are working with the GPT capability across the company. So all the clouds within Salesforce are actually going to adopt the GPT capability and the LLM the LLM models. So we are going to incorporate some of those features into the studio, or not in studio in this case, but the VS Code based editor as well. So the code builder will actually have some of the GPT capabilities incorporated. What are the exact capabilities and when you are going to get that? I can't share that right now, but you will see some details coming out during the Dreamforce. So stay tuned because you can actually watch some of the sessions. So we will share some of the details during that sessions.
It write code?
Sorry?
Way to write code as well?
It will do to a certain degree, because it's gonna learn from the code bases, like the trusted code bases that we have within the MuleSoft, and it can output some of the things for you. For example, if you want to map certain data elements, it can you can ask, how can I request the object A and B from Salesforce connector? So it's going to tell you exactly what to do, and it will produce some of the results as well. So, yeah, it's going to simplify. It's not going to be everything, but yeah.
Then we are also
The final bit around the product is actually the automation. This is the RPA product. So we have had quite a lot of details and the changes coming in. So if I added all the features and changes here, we'll be just speaking about this today. So I included about 3 or 4 latest changes here. So one of the latest features is the credential pool with user control. The next one is the enhanced web recording. So there are more changes may have happened since I actually pulled these slide decks. And the other things in the pipeline is actually the enhanced IDT capabilities and then the decision management. So these things actually makes it quite easy for you to use and makes your business process to automate quite faster. So if there are no other questions, I'll jump ahead to the next section, which is pretty much go and check in our online events group within the meetup.mulesoft.com. So you will see all the global events, because there are certain events that's happening just online events, and there are certain groups that's available like us throughout the globe. So just go there, look at what's happening in there. You can see the list of events from the website. With that, I will actually hand over to James, because this is about the MuleSoft Mentor. We have been always talking about this one. This is about you giving back to the community, you getting recognized, and you being part of the community for more and more interactions. Over to you.
All right, I will just share screen.
Stop sharing from my end.
How long? Till 7 on the. Do I have a bit more?
You have
A bit more? Yeah. Okay, great. Well, look, thanks for having me here, and yeah, I really appreciate the opportunity to talk and talking about a concept of data mesh, which I don't know, it's certainly kind of raising awareness. More people are asking about it. There are questions about it. So today I'm just going to talk a little bit about the theory of data mesh, and also kind of like how event streaming plays into data mesh. So my name is James Gollan. I'm from Confluent. To bridge something really early, MuleSoft have connectors into and out of Confluent and Kafka, and so event streaming is something that kind of like is very relevant to MuleSoft. If anybody's wondering why I'm at a MuleSoft meeting. So starting out, what I'm going to cover today, I'll just move my event mesh and data fabric, kind of like how those two concepts relate. And then I'm going to just like talk a little bit about event streaming, because it is like quite a different way of dealing with data. And then move into actually a practical demo of just like looking at a data mesh running event streaming platform. Because we're a small group, like happy to like take questions, debates, and those kinds of things during the talk. But I will just kick on. So how many people have heard of data mesh? Is that no? Okay, well, that's good. Yeah, a few people, yeah. Okay, well, then we'll start with the data mesh principles then. So data mesh kind of is a recent sort of like idea, and it came from this the reality that big data was supposed to transform organizations, and but the way that we've implemented these big data projects has seen them not really deliver the value that we expected. And so data has been treated as an asset, and we've been collecting it. But we haven't actually been getting the value. There's little sort of things like $1 million for the first report and those kinds of ideas where it's very expensive to get data into that data warehouse and then actually get value out of that. So this is a quote from a ThoughtWorks white paper. A very little bit of brief history, not really history, but gives you an idea of where we've come from. So back in the 70s, online transaction processing systems, you know, obviously dealing with transactions and storing transactional data. But over time, as we started collecting that data, people wanted to actually analyze that data because there was some historical interest in that data. But these systems weren't great for actually running two processes at once. They were good for the transactional, but not for the analytics. And so we started moving the data out of those systems into data warehouses. And then as systems, these transactional systems started to sort of like pop up everywhere, more and more data was actually moving into these data warehouses. And actually the process of moving this became kind of like an industry in itself. And we ended up with a lot of this data in these data warehouses. And so because it was such a big problem, there's so much data moving, we moved to these centralized data teams. And so they were responsible for integrating with systems, but also interpreting systems, normalizing the data and making sense of the data. So that's kind of the background to where data mesh came from. These big data projects, not actually sort of like delivering value. So the concept was actually first spoken about by somebody from ThoughtWorks, Zhamak Dehghani. And it really was based in some research as to why these big data projects were failing. And like the aim of data mesh was to address the limitations of these centralized data architectures. And they're sometimes also called a data monolith. And I'm sure kind of like you're familiar with the idea of monoliths through kind of like, you know, microservices would be a big part of kind of like where you work. The important thing here, well, there's a few important things. One is it's technology agnostic. So it's actually a set of principles rather than a specification of which technologies you should use. And so obviously it's open to interpretation as to kind of like which technologies are most appropriate. But the goal is the same. It's basically just unlocking value from data. Because we're collecting a lot of data, but a lot of it is sitting in kind of like, you know, you would have heard the term, or you may have heard the term data swamp. That's where kind of like it was a lake, but it's like just gone stagnant and nobody knows what's in there. It's kind of like nobody really wants to go in there. So a couple of things. Data mesh evolved in an analytics space. And this hopefully brings it more relevant to like the MuleSoft community. It actually also, you know, we think it's sort of like is also operational. So kind of like I suppose the approach we take is that, you know, an organization's data is its data. It may drive operational use cases. It may drive analytics use cases. And increasingly, there's a sort of like blurring line between the two. So you get some analytics workloads that are actually used for operational outcomes. The other thing that, like I've just mentioned, is that there's a couple of terms that you'll see. There's like this data monolith, and we'll be talking about domains. So these are terms that you, again, you may be familiar with in that move from kind of like the application monolith into microservices. So they're very similar ideas. And in fact, data mesh has been referred to as microservices for data. So that gives you an idea of sort of the flavor of what's going on here. So to the principles. There's 4 principles, and there's 2 that I think are really key and 2 that are important at supporting. And I think the first 2 are the really key ones. And the first one is this domain-driven ownership of data. So one of the failures of these central data teams actually managing and processing data and capturing it from, you know, different systems of record and files and those kinds of things was that by the time it got to the centralized team, they were so far away from the actual generation of the data, they didn't even understand kind of like what a schema was, what fields meant what. And so we got a lot of like misunderstandings, misinterpretations, and so like around the data, and that's really critical. And so first principle is that we actually move this back to within domains. And so we're going to be talking a lot about like domains driving their data, being responsible for their data, and understanding their data. But then we move into this principle 2 of data as a product. And I think this is probably the most critical because data as a product is different from what I said before, data as an asset. Because data is an asset you collect, you protect, the more of it, the better. But it's not necessarily there to be accessed. Whereas when you start thinking of data as a product, it immediately shifts the way you think about data. And you think about, there's actually an end user of this data. So we actually now have customers for the data. Those customers may be external, but in the data mesh context, they're typically an internal customer. And that's where we get into those domain and product. So these products are made available across domains in a place where we can like create a cohesive product that is well understood, governed, etc. So domain-driven, data as a product, the key ones. Self-service data, if we're moving this responsibility back to the domains, we need to give them the tools and the ability to actually build this without relying on a central team to deploy all of the infrastructure, etc. Because remember, this is kind of like, that was the point. The centralized team is a bottleneck, it doesn't understand the data that well. So the more we can move to a self-service platform, the better. And then finally, this data becomes really critical across the organization. It's being shared across domains. So we actually need governance. We can't avoid just by saying, oh, it's a domain problem. The moment it crosses that domain boundary, it needs to be governed in a way that's understood across the organization. And so that's the sort of federated computational governance. Does that all make sense?
You could nearly replace data with API there, and you'd be ringing the MuleSoft bell, right?
Oh, sure. So looking at that in terms of an organization, this represents the organizational boundary, so everything inside is internal to the organization, everything outside is other organizations, and we have this idea of domains. And so within this circle, which represents the domain boundary, we have systems and applications, and they're talking to each other. Now, they may be talking to each other via sort of like your REST APIs. They might be using sort of like event-driven microservices, so they're actually passing messages via events. But regardless, anything that happens in here is really kind of like a free-for-all in terms of the domain, because they can understand kind of like the data, the fields that they're using, because they talk that domain-specific language. It's a shared vocabulary within the team inside the domain. But that doesn't necessarily cross into other domains. And you probably have seen it before, where even something as seemingly kind of like well understood as a customer, in different domains, it can actually mean different things. It can be different data structures, and it can actually, and particularly with acquisitions and things like that, it just gets messy. And so what we do is at the domain boundary, that is where we provide our data products. And so these data products are now discoverable across domains, and domains can get a reliable view of the data products that are produced by a domain, and it will be well understood. So that's data mesh. And data mesh, as I said, it's a set of 4 principles, technology agnostic. So it sits kind of like at quite a high level. But in order to implement this, you actually need some kind of data fabric, right? So a data fabric is a lower level concern. It's almost like plumbing for your data. And so what we need in a data fabric is obviously you need to be able to integrate lots of different sources, both source systems and sink systems, so destination systems. And you basically want to unify the patterns for accessing that data across the organization. You want to be able to actually do this in real time, because remember, all of the data of the organization will be flowing through the data fabric. So it's kind of like the weakest link in the data fabric, like the highest latency becomes sort of like it becomes built into the data mesh. And so latency, particularly for real-time operational use cases, incredibly important. And then finally, across an organization, these data fabrics need to scale, because as you can imagine, organizations have so many systems, more coming on all the time, whether they be SaaS systems or legacy systems, or even CSVs sitting on this folder. So it needs to be able to scale to incredible levels. So that was kind of like it for data mesh, which sits kind of like at that top level. It's built on top of the data fabric, which allows you to integrate systems in a kind of like predictable and reliable way. And now we're going to just talk a little bit about event streaming. So I asked how many people had heard of data mesh. How many people have heard of event streaming? Yeah? Good? Yeah. Yeah, so quick overview, and like this, you would be familiar with this idea because it's a problem that MuleSoft deal with as well. It's this idea that over time, organizations have become this kind of spaghetti architecture of point-to-point connections. And so ESP systems that are brittle and that they're hard to maintain and they don't scale. It's like they scale basically exponentially in terms of how many connections you need as you add more systems. And so this is kind of like the current reality of many organizations. And many of those systems are kind of like storing data in databases. And so this is where we sort of like start with this idea of data at rest. And so databases are obviously a critical part of every organization. They remain a critical part. Event streaming doesn't take that away. But they do have a sort of like a foundational assumption in that they store data, and then when you want to find out the current state, you actually query the data. And so typically these will be static queries. And oftentimes when you actually want to take the data that's accrued, you do that as a batch process. And so that might happen overnight, and it goes into a data warehouse for further analytics. And so when we talk about data at rest, that's kind of what we're talking about. And I suppose it's a bit of a marketing thing, but it actually has some meaning to it, data in motion. And so this is kind of like this idea of data in motion. So you have systems that are generating events. So events are core, and an event we can see here in the real world as being a sale, a shipment, maybe it's a parcel scan in a post office, it's a financial trade, a transaction, a payment. These are actually real events, and the idea behind event streaming is that you can capture these events as business facts. So when they happen, you capture the data that represents the event, and then you push that into an event streaming system. So that's kind of like the fundamental premise of event streaming, where as events happen in the real world, they're captured and pushed into the platform, and then they can be processed in real time. So we can enrich and join, and we're going to be doing some examples of that. And then they can be pushed through to kind of like end systems. So you can get lots of systems that are subscribing to these events. And so that's the basic pattern. The fundamental, I suppose what's really different about event streaming, or let's just say Kafka, so if you've heard of the open source project Apache Kafka, is that all of this, what's that on transition? Is built on this idea of an event log. So we just mentioned that events are happening in the real world, and as you can expect, like they've got a timestamp, they happen in an order. So events are basically appended to the log as they happen. So what we end up with is a series of events that form this log. And that's a very simple idea. It's a very powerful construct. So Apache Kafka, the open source project, is actually just some APIs to allow you to read and write events to a distributed log. It's a really simple concept, and it's quite sort of like a pure concept, but it has been like, it's been quite sort of like revolutionary in terms of how much data it can process and how quickly it can process that data. There's a lot of technology behind that. That's essentially sort of what we're talking about with event streaming. I think, yeah. So like just a couple of things, and this is why is it good for data fabric and data mesh. First of all, real-time low latency. Okay, so we're talking in the milliseconds. So if you're talking about a financial trading system, you're probably talking about nanoseconds, and so it's not that. But millisecond latencies are kind of like what we expect. Highly scalable, and I mean highly scalable. So basically, it's a distributed system. You just either, obviously, Confluent have a cloud service, so you don't have to worry about that. But there's also, if you're using Kafka, you can just add brokers into the cluster. And this one kind of like, because up until this point, you're probably thinking, oh, pubs are maybe message queue. Is that what we're talking about here? It's kind of is, but there's more to it. And so one of the really big points here is storage. So these events can actually be stored. And by default, a topic of events is stored for 7 days. That can be made shorter if you don't have a need to store them, but it can also be made longer. So we can actually store events infinitely if we want. And so that means that it can actually form a source of truth across an organization for those data sources. And then sort of like probably the other kind of like important impact of that is that we can replay our events. And that can have some kind of like real benefits when you're sort of like recovering from issues with applications downstream, etc. The ability to replay events, get back to a state is very important. And then finally, I'll just say the immutability of streams, right? So an event goes into a log, and it's like double entry bookkeeping or something, where you never sort of like, accountants don't use erasers. They basically create correction events. So once an event is in the log, it's immutable. It never gets changed. So that was all about the kind of like event streaming, data fabric, data mesh. We're going to go into a demo. I'll just sort of like explain what's going to happen in the demo, then we'll walk through. Any questions so far, or is this kind of like making sense? Or yeah, okay, good. So the demo. So I'll start with an overview of the scenario, and it's obviously a simplified scenario, but it kind of like it can actually be extended to sort of like much more complex ecosystems and data organizations. And so I'm going to start. The loyalty sort of like centers around these 3 domains. So we have a loyalty domain. So we have kind of like loyalty applications that are capturing loyalty points at points. So we've got customer domain and credit. And so in the loyalty domain, somebody scans their card at a point of sale, that's captured. And we consider that fast moving data because people are doing this all the time, right? It's a large, you can replace this with credit card transactions and that kind of thing. And that's kind of like, Confluent and Kafka are used for credit card transactions and fraud detection, that kind of thing. But you get the idea that there are some systems within your organization that are producing a large amount of data. And so this P represents a Kafka producer, and it's being produced into what you might recognize as the log. Okay, so we have a log of these loyalty events. In the customer domain, we actually have what we might consider slow changing data, right? So I don't want to say like slow moving because it still needs to be instant or near instant. So we still need low latency, but this system doesn't change that much. Okay, it's not changing that often. People aren't updating their address that often. So we consider it slow changing. And I've said MySQL here, but it can be any system of record, so any database, and kind of like even other systems of record. And so the way that we actually capture those is via change data capture, which you may be familiar with. So change data capture is a really kind of like a nice approach to integrating databases, because what it does is it listens for any sort of state mutation in the database. So every time that database is updated, we can actually turn that into an event. And if you think about the real world, that's kind of like the database is almost a proxy for the real world event, because somebody did something, they changed their address, that was the event. We haven't captured it as an event at that point, but our old system, our old legacy system is updating its data store. And so we can actually, we can sort of like mine for that event via that change log. And again, we've got these kind of like events going into a different log because they're a different type of event. And then finally, we've got some CSV files, which we would very much consider batch, right? And so this is in the credit domain. The scenario is we're getting credit rating scores from an external agency, and they transfer via files. And like it sometimes seems surprising that that still happens, but it's still a real thing. So again, we use a connector to essentially monitor an SFTP server for when those files arrive, and then they're actually processed. Each row of that CSV gets turned into an event. So what we end up with is all of these events, and they're actually all being stored in the event processing system, which is Confluent here, but you could replace that again with Kafka. And then finally, we're doing some processing, and then we're going to push these events down to some of these downstream systems. All right, so we're going to be pushing into MongoDB Atlas, and we're also going to be pushing into Amazon S3. Now, those are just some random examples of sort of like cloud services that you might want to push to, but there are lots of connectors both for getting events in and also for getting events out. Does that all make sense? Yeah, we're getting to the demo. And how are we going time-wise? Yeah, not too bad. So, demo scenario. So data mesh is really, in some ways, it's not so much about developers. It's about kind of like, domain teams. And you might imagine a product manager like being interested in the data that's available across the organization. All right, so here we have a product manager, he's in the customer service team, and he wants to build an application to improve real-time knowledge of customers' loyalty points. So he wants to understand how many points the customer has, but they also need to access details about the customer address. And finally, they need to access information about the latest loyalty transaction. And so basically, this product manager is going to be building this product. And sort of day one, what data do I have available to me? So that's where we move into the demo, and we'll see how many things. You see, no, it's kind of funny. Just get rid of that. Get rid of that. All right. So I'm going to be just like logging into a Confluent Cloud organization. And again, this is a cloud-based service, but we also have on-prem, very similar, like MuleSoft. That's common pattern. Okay. And then we move into, I won't go through the whole, this isn't about sort of like Confluent Cloud interface, but like if you were kind of like administering a cluster, you might come in and you might find your Kafka cluster here. And so for an administrator or a more technical person, this might be the approach they take to kind of like the cloud. You're going to leave or you? All right. Yeah, but like as a product manager, I'm not really concerned about like how my cluster is running. I'm actually much more concerned about, well, what data is available to me. And so in that customer scenario, I'm going to log in with credentials. And I should preface this has all got obviously role-based access controls, so like very tight access controls. I'm logged in as basically the root user for this cluster. So I'm going to see everything, but the product manager would likely see a small subset of what I'll see. But I start by just going into the catalog and saying, well, show me anything that's for the loyalty domain, because I'm building something around loyalty points. And so I get a listing of all of these resources that have been tagged with the loyalty domain. I can also see some of these actually have been tagged with data product as well. Okay, so if you remember back to that sort of like organizational boundary, these are the things that are published on the organizational boundary. The reality is, as a user logged in, I would only see things within my own domain and data products because they're organization-wide. And so I can see a number of kind of like assets here. I can also read a little bit about this data set or this data product. Okay, stream of loyalty transactions from vendors, point of sale, contains customer ID, but so a little description of what to expect from that topic. And I can scroll down and I can see I've got some other topics here. There is a naming convention that's employed around, and this is completely up to the individual business how they decide to do this. But here we're saying organization, which means that the scope is organization-wide, right? And then we say loyalty because the domain that's actually controlling this is the loyalty domain. And then we say transactions because they're the transactions that are actually occurring. And so we can see kind of like, as I said, some other resources. One of the interesting sort of resources down here is actually a connector, which is pushing through to S3, but we'll look at that in a second. So as that product manager, like I'm interested in organization loyalty transactions. And so I click through and I can start to see sort of like the production and consumption. This is being produced and consumed by Docker. So that is where my laptop is closed and it goes back up when my laptop is open. And so I can get an idea for sort of like how much data is actually moving through this. And it's normally, bytes per second, etc. On the right-hand side, we can see information about that data product. So part of my decision-making process needs to be, well, how can I rely on this product? And so I can see here that this actually has a status of GA. It's got tier 1 support across the organization, managed by the loyalty team, organizational scope. And so I'm still interested. This looks like it might be useful to me, but I might want to understand, well, what kind of data will I be getting? What's the shape of that data? And so for that, I actually look at the schema. And so one of the key things about that computational governance is that topics, we need to understand and control the schema and also the schema evolution. You'd be very familiar with that, API evolution, same thing, right? And so this actually tells me kind of like what the shape of that data is, the types of fields I should expect. It also tells me the compatibility mode. So that basically controls how this schema can evolve. And with data mesh, it becomes really important because you've got so many systems relying on this that it's really easy to evolve a schema if you don't have those controls in a way that breaks other applications that are actually relying on it. So a really important part is this sort of like schema evolution. And so again, I look at this schema, it seems to have some fields that might be of interest. But the next thing I might want to do is understand sort of like where it sits within the flow of data within the organization. And so for this, I can actually sort of like inspect much more of a sort of like a lineage view. So what this is showing me is that we've got a point of sale producer that's producing data, and then it's going into a number of topics. And you can see as I hover over, we can see the upstream and downstream kind of like paths for this data. And so what I can see is there's some upstream, and I can see here that this data is actually, so actually I should probably zoom in a bit there. This data is going into a raw transactions topic. And sometimes it's the raw transactions, the ones that haven't been processed at all, you want to push into a data system like an analytics system. And so in this case, what we've done, oh no, I didn't do that. What we've done is we've actually branched off. So every event that arrives in this topic is being pushed through to S3. That might be for an archival use case or something like that, but it's actually just being pushed through via sort of like fully managed connectors. But it's also going to another downstream query. And so we can see this like flow. Now, if I was to look at this and then think about that sort of like demo overview I gave, there were actually 3 data sources. But I'm only seeing one. The one that I'm seeing is actually the fast moving data set, okay, the loyalty points, because people are still scanning their loyalty cards and they're being captured in the system. But I don't see the other 2 systems. And that's because, like, I mean, a big part of event streaming, I guess, is time and time windowing. And so we're just looking at the last 10 minutes of data to be flowing into the system. So if I increase that, I start to see over the last 24 hours all of the different systems that have produced data into Kafka. And so I start to see those others like CSVs, etc. So as I move down this topology, I can like look at other topics and see if they're more suitable. And eventually, spoiler, I'm going to choose this organization Customer 360, right? Because the Customer 360, if I click on it and we look at the description, it's a representation of the the current view of customers, credit information, loyalty points, useful for building applications. Okay, so that's what I want to be building my application from. So the final thing is to, I suppose, step out of the path of the product manager and just see kind of like how we're actually dealing with this data as it flows through the system. And so for that, we're going to go and look at a stream processing engine. So a big part of event streaming, if you think about those logs, those topics with all those events coming through kind of like all the time, stream processing is the ability to listen to those events and react when something happens. And that might be as simple as filtering or reshaping the data, but it might be joining the data, enriching the data, etc. And so in Confluent Cloud, and this is again, it's under a community license, KSQLDB, but this is available as fully managed in Confluent Cloud. And so what we're actually looking at here is very similar to stream lineage, but this is much more at the kind of application level. And so we can see we've got kind of like our domain loyalty status stream, right? And we've got our customer's raw stream. And this is kind of like probably an interesting place to start because as we look at all of these events that are flowing through, that's what the data is looking like in an individual event. So that's the real data. And what we see here is kind of we've got before, after, and we've got source. So this is a really common example of a CDC data kind of pattern, right, or a data object. So it's capturing kind of like the before value, the after value, but also a lot of information about the source system that actually generated this data and when it was offloaded, etc. So it's a great example of some domain-specific data because within the domain, that might be really important. But if I'm outside of that domain, I just want to know about customers, and you give me that data object, it's kind of like horrible, right? You don't want to work with that because I don't understand half the fields and nor should I. And so the first thing that we do then in this topology is to just say, well, take all of those events and as they arrive, process them into another stream. And so what we see here is the stream of events that have been processed. And as you can see, it's a much more structured, clean object that represents a customer object, and we can kind of see that, right? And so what we've done there is done a lot of kind of like cleansing, and you'll also notice that this is now organization-wide because this is in a format that is suitable for that domain boundary as a data product. Because this is a product, the thing before was an asset. Yep. And so without sort of like, I suppose, belaboring the point too much, all of this processing is happening and is captured here, and we can start to like create some interesting things around stateful aggregations. And so if we were to look at the loyalty transactions as they flow through, and we pause that and just take a look at one of these loyalty objects. So this is what's happening when a card is scanned. It's capturing a customer ID, points, the vendor, and the transaction ID. All right, so it's capturing some data, but it's not capturing anything about the customer themselves. So if I wanted to actually look at all of these loyalty transactions by postcode, I've got some work to do. And so we do that work by actually using stream processing. We actually join these objects in real time to create a more complex object. And so we can see, I'll just go straight to the final example of this, which is where we bring in the 3 different data sources, the batch, the slow changing, and the fast data, into a customer 360 object. And so this customer 360 object, just pause it there, you start to see it's now a much more complex object. It's actually got a mix of state and sort of like, oh no, it's all stateful really, but it's got a mix of the types of data that it's capturing. So what we see here is we see the customer ID, but we also now start to see first name, last name, and address. So we recognize that from the customer system. That's where we caught it. But we also start to see information about the loyalty transaction. And that's coming from a different system, but it's being joined together. And so here we see that stateful piece, which is latest loyalty transaction for this customer. And then a bit further down, we see an aggregation of the total points for the lifetime of this event stream. And so this is actually an aggregation around how many points this customer has actually accrued and the average points per transaction. Interesting thing, because you might start thinking, well, 7 days of data retention, what happens after 7 days? This state is actually stored in what we call a compacted topic. So we always keep the latest version by key, which means that your key space will be your customers. And so we'll have 1 entry per customer, which is constantly updated. So the final part of this, and there's kind of like, there's more parts to this, but the final thing that I'm going to show is kind of like, and it's a very rudimentary application, but we can see here is just an application that is actually capturing that customer 360 object. And what we'll see is, and I'll just refresh this because yeah, so each time you see kind of like one of these customers flash, there's been a change to their account. And so what we see here is as people are actually accruing loyalty points, the system is updating in real time or near real time, depending on your definition. We can actually see that because if we go into sort of like Frederick here, customer 101, we can see some details about Frederick. Now I can go into my customer database and I can change, say, Frederick's name to Fred and save that. And I come back to my view application and that's been updated, all right? Now, just to understand what's happened there, I've updated a MySQL database, and it could be any database, it could be Oracle, it could be those kinds, but I've updated a MySQL database that's been picked up by a connector running locally. It's then pushed that into Confluent Cloud, into that source topic. It's gone through that entire processing topology. It's then being pulled back down by another connector that's listening for changes. And it's all doing that over, like Cloud works, but like, I don't know what your network's like. I'm sure it's very good. But it's all doing that over the public internet, over kind of like those network latencies. And it's happening kind of like in near real time. Yeah. So look, that was probably a lot of talking, maybe too much talking, I'm not sure, judging. But were there any questions or anything that kind of like didn't make sense? Or? It's time for me to grab a beer.
Okay. Just a quick one. Thank you so much for that. That was great. In relation to domain definition, you obviously talked about the fact that, and we see this with APIs when we're trying to orchestrate this that way as well, it's very hard to get the right people to come together and take ownership and define these things. Be interested to hear your thoughts on that.
Like it's actually the biggest issue is like decentralizing, pushing back to domains. It becomes a people and process problem. Like the technology problem is almost the easy bit. It's actually getting people to agree to own their data and publish it, and agree to even use data that's on the like data mesh. Because you'll get kind of like developers who are doing it one way and they don't want to change and that kind of thing. You get kind of like issues around kind of like, well, who's going to pay for this and that kind of thing. One of the things that we do see though is kind of like almost internal marketplaces. So if you think about data as a product, the one thing that we haven't touched on is, the payment for the product. Like you normally make the product and then you sell it. So internally within an organization, that may look a little bit sort of like different, but the idea of actually creating a marketplace of data within the organization and doing showback, chargeback, or even charging internal domains for using that data. So it incentivizes you to make a good data product, and it also pays, it's sort of like, and then you will pay for other good data products so that you can build applications that make sense. Yeah.
And what about the orchestrated data object? So the end at 360. So let's assume you've done the domain-driven
Who owns it?
design and who owns it, and that's all great. You're amazing you've got there. But when you orchestrate at the end, how do you think about that 360? Is that someone who owns it and understands it backwards, or is it kind of a, how do you think about that?
Yeah, look, I mean, it's a great question. Actually, like I could almost answer it in the MuleSoft way, which is kind of like that hierarchical APIs. Okay, so you've got your system APIs, which are basically those raw topics that really represent what changed in the database.
Yeah.
Then you've got kind of like those process APIs, I think, and then experience APIs. Yeah. So that almost sits at that experience API where you're building that. And if you look at that data object, it's not going to be broadly useful across the organization, but it's very useful to this team. And so a lot of, when you think about what it takes to actually build this application, it's all just being sunk into MongoDB as a single document, and it's upserted every time there's a change. So we've got 100 records in MongoDB, and this application is really saying, just give me this document by this ID. And the guarantee is that when I do that, it's being updated because the database is being, hydrated from Kafka. Yep. I won't go through kind of like, data quality. I won't go through this because I'm mindful of time. But the idea that the data, when we're sharing across the organization, it's really critical that we actually understand not just the shape of the data, but the type of data that we have, and that it maps those social security numbers, look like social security numbers, those kinds of things. And also that these data products can actually exist at an organizational boundary as well. So what we're seeing is kind of like more and more organizations starting to share streams of data because they're relevant.
I just had a question on that. I mean, maybe we see a little bit of the reverse going on in terms of, CDPs and stuff like that, which we commonly associate stream processing with. But I hear a lot of people talking right now about like reverse ETL, which is, passing back to the other domain. And, we think about that in terms of, activations out of a CDP. But is reverse ETL, how do the streamers think about that concept?
We don't really understand why you need to do it, to be honest. Like, if you were to have a sort of like, you've got your source systems, you've got your event stream, and then you got your sync systems. We just see kind of like those data warehouses as sync systems. Sure, they run analytical workloads, but if you're doing some transformation on that data that actually needs to get back to the organization, you're actually investing in latency if you're going to do the whole reverse ETL thing. We would say that you manipulate the data into a shape that actually suits the use case, and then you subscribe to that. Like, I don't know if that answers your question, but yeah.
So like, can you do a reverse of the stream, like you have a SQL data?
Yeah. And so, like, I mean, what we probably didn't see there, but it was actually coming out of MySQL, and then it was going into MongoDB. But you could replace MongoDB with MySQL. You could replace MySQL with MongoDB. So you can and you can have, like, it's not just one system. I could have both. I could have MySQL and MongoDB and S3 and whatever else I want to, wherever else I want to push the data. And it doesn't require any change. It's just another consumer of that event stream.
Kafka actually offers different set of libraries. For example, you have the regular MuleSoft operated libraries as well as the stream libraries.
Yeah.
In the demo that we saw, it's pretty much like the stream operations, which is like the joins and the time-based operation, time series operations. They are all built into Kafka in this case. how can someone use the libraries that Kafka offers and externalize that logic into their own domain? For example, the thinking back that I'm coming from, Kafka as an application is going to be managed by one team.
Yeah.
But it's going to be used by multiple business teams.
Yeah.
Putting the logic in the Kafka application and asking one team to manage all of this is not going to go well with most of the team because operations guys, they don't understand the logic.
Yeah.
The domain team need more control of the logic.
Yeah.
So that way, like, can we use the libraries to delegate that processing part to someone else?
Yeah, and so one of the things that we kind of like didn't really like see, but when we went to KSQLDB, this was just like a cluster. So this is an application running, and so KSQLDB or stream processing runs alongside, but separate to Kafka. So there's no kind of like stream processing that happens in Kafka. Kafka, again, it keeps it really simple. It's a read API, a write API, and a streaming API. But the KSQLDB application can be owned by a domain team, so they can actually build their own transformation. So to your question, the team, the customer team or the support team that wanted that data product, they may be the ones who actually built that stream processing logic, and they may maintain that for themselves. It doesn't have to be shared across the team. So yeah, so like I don't know if that answers your question, but kind of like it gives teams the ability to run either fully managed, but also like, I mean, you know, we've got customers who use Flink, we've got customers who use K-streams. Again, they're just reading from events and they do their stuff and then they write back into another log. So you end up with kind of like these different steps represented in your topic topology.
Just a follow-up question on that, like that, thanks for the explanation. If I use the libraries, let's say from MuleSoft perspective, like most of the people in here are MuleSoft developers, so they just use the Java library for the stream process and then like write one of those logics. Where would that logic actually be like deployed and then executed?
So MuleSoft have connectors for Kafka, so you can actually ingest. You can basically, like, you know, I showed a couple of like consumers, but MuleSoft can be a consumer of that. So MuleSoft will be updated in the same way that this database was updated every time something changes. Once you've got that data and you've got that it's happening kind of like in real time because those are like guarantees. You can do whatever you like with whatever tools you like within MuleSoft. If you want to share that across the organization, obviously with MuleSoft, you can put it behind an API or you can write it back into the event stream. So it's very flexible in that way. Yeah.
So you mentioned about Flink. So where's the Flink fits here? Like, you know, on a KSQLDB does all the time, you know, streaming.
Yeah. So broadly speaking, there is stream processing. And then there's lots of technologies that approach it. So KSQLDB is one technology. It's actually built on top of Kafka Streams, which is like a Java library. And then Flink is just another separate project. There's a distributed stream processing system. All of those systems, you know, I suppose the key is in stream processing. They need something to process that comes from a stream, so that comes from Kafka. Or, you know, there are other like technologies that do event streaming as well. I don't want to say Kafka is the only one; it's just the dominant one. Yeah.
Because why I ask is from a Confluent point, you already have KSQLDB. Then why you start looking? I seen something that Confluent is supporting Flink. So
yeah.
Is there a reason why it's just other support?
Yeah, there is. Like, I mean, there's sort of like there's a strong developer community behind Flink, but Flink is like more mature. Probably like KSQLDB is very good for the kind of stuff that I've just been showing. For things like anomaly detection, so say you want to look for a pattern on a stream. So say you've got sensor events coming in, and I want to know when something spikes because I need to turn the machine off. And so in the mining industry, that's the kind of thing that they do. And so that's not an easy thing to kind of like, you know, it's very doable and solvable, but it's not an easy thing.
Best tool out there.
Whereas Flink has just a query which basically defines pattern detection. It says, show me when, like you define it very simply through a SQL interface, and then suddenly it's actually doing your real-time monitoring and alerting against like streams of data that have gone outside of what you consider to be normal. Yeah. Cool.
My last question.
Yeah.
In terms of the method, not the methodology, it's actually like the definition on the basis of like what we just heard from you. What's the overlap between that, in your opinion? What's the overlap between the complex event processing and the data mesh from the principal's point of view?
Okay, complex event processing. So, like, I mean, the overlap, I mean, you may use that to create a data product that, you know, represents the output of that complex event processing. So actually, you know, complex event processing, that pattern detection is a pretty good example of complex, but you may also have sort of like a stateful complex event processing where it's not enough that one event has happened. I need 5 events to happen. I need them to happen in a 30-second window. And that's the event I'm interested in, when all of those things complete or fail in 30 seconds. So that itself becomes a very valuable event stream because it's telling us something has happened in the business that we're interested in. Yeah.
So it's more like kind of like the data mesh actually enables the CDP as like one of the use cases.
So the data mesh may give you the data products, the input, but you may also want to publish it as an output, as a product. Yeah. And I should say, like, data mesh is a fairly new thing. So, like, I mean, you know, people are trying, people are failing, people are succeeding. So it's not to say that this is a sort of like a done deal and everybody knows how to do it. And it will vary across every organization because of those people and process issues. So, yeah. Cool. Thank you.
Thank you very much.
Oh, like, yeah, I don't know. If anybody's interested in finding out more, there are these QR codes. The one on the left-hand side is actually a really good book on practical data mesh built with event streaming. So if any of that is kind of interest, that's quite an in-depth book. On the right-hand side, it's just a QR code to sign up for Confluent Cloud. If you want to try any of this, there's lots of tutorials to get you started, so like the way you like. Yeah.
Thank you, James.
Cool, no worries.
And now we're back to Harshana, who is going to talk about the unification of data products with Anypoint DataGraph. Over to you.
Thank you very much. So in this particular case, I do have a demo, but I'm not going to do the demo. It's a recorded demo. So unfortunately, the data graph needs a bit of bandwidth. So I'm not sure I could actually accommodate it. So I got one of the recorded demos to come here. In this session, we are pretty much going to cover following topics. We are going to talk about the data mesh principles, which already covered, so I'm not going to dwell on that. We're going to talk about the GraphQL, which is the technology behind the Anypoint DataGraph. And then, of course, we are going to talk about the technical details about the DataGraph, followed by the demo. And then, similar to what we just saw from James, the next steps as to what you can do and how you can try things out. So the data mesh principles, same details, just a different presentation. So you have the data mesh built on 4 different pillars, 4 key principles, the same thing. So after
It's good that they're not 4 different principles.
yeah. So from what we just learned from that particular demonstration from James, you already recognize that there are a couple of very different domains in your enterprise and how you can actually come up with these different domains and how these different domains are actually going to dictate how your data elements, how your data products, data assets are going to come up with. So thinking about enterprise and then coming up and then thinking about how you can actually enable the API-led architecture and how you can create a composable architecture out of the domain-driven architecture pattern will actually go something like this. For example, we'll have multiple domains. So we have the product domain, I have the customer domain, the payments, and the fulfillment. So think about this as typical 4 different departments within the same organization, but they have their own different things, processes that they work on. So you will have actually, in idealistic world, if they follow everything that we tell you to implement, for example, C4E, you will have a federated development model. Worst case scenario, you don't have a federated model, but you have a centralized MuleSoft development team, so you can still get things done from the domain team and delegate it to the central team, and they will do the development on behalf of you. So to start with, we'll have the product team, which is actually getting the store API, and then the next API is the marketing API, because this is actually about the product marketing and then the product story. The second team is actually the customer domain. So obviously it's going to be actually fronting the customer API, which is also done Salesforce. And then there's another system that's actually looking after the loyalty. So there's quite a bit of overlap between what the demos are going to do. And then you have the payment, which is probably through the Stripe. And finally, you have the fulfillment. So you have the delivery API, and you're going to have the inventory API, because this is actually where you actually fulfill, and these different business processes are actually going to need to talk to each other across the boundary of that domain. Because if you think about that business process, how can you actually provide a store and order function without actually talking to the fulfillment? You have to talk to these different departments, but in reality, it's completely managed of their own. So you actually come up with your process API layer, which talks to these different things. But the process itself is actually owned by one of the domains. So in this case, it's a product API. The product API relies on the store, the marketing, as well as the delivery. Similarly, you have the order API, which is again owned by the product domain. Now I need to talk to 5 of these underlying system APIs. Now we have the third API, which is the customer profile, the customer 360 from the example that we just went through. Need to talk to Salesforce, Stripe for the payments, and the loyalty details. Finally, we have the shipment API, which is owned by the fulfillment team, which need to talk to inventory as well as the delivery API. So this is how the typical boundary of that the organization will work. And some of these processes actually need to talk to across the organization, across the 2 different teams. But you can actually get that ownership into your domain and manage those data assets, and then use the APIs to go across the boundaries and access those data elements. So you can get this particular model implemented quite easily. Now, you need to actually expose these details into your own consumers. So that's where you have the experience layer coming in. You have the partners need to access the product as well as the orders. And then you have your web front end, which need to talk to all 4 the process layer APIs. Similarly, you have the mobile app, which need to talk to again all 4 of these layers. And then you're going to have different omnichannels coming in. So depending on which omnichannel, you might pick and choose which APIs, which process APIs need to be talked to. So this is all good and well. So what's the problem? You get to this point and think about adding the next experience layer, because you're just bringing in another consumer in the picture. So you can already say, even within the API-led connectivity layer itself, things are starting to look a little bit of a messy situation. So rather than this, can you actually come up and simplify the whole architecture? Of course you can. So this is where the GraphQL comes in. So rather than your consumers need to know about different data products, that means you have a data asset called product, you have a data asset called customer, you have another asset called shipment. What if you simplify the whole thing and then provide a more simplified single user interface that you can, the consumer doesn't need to think about what the relationship between these APIs. So that's what you get from the GraphQL. Because when you use the GraphQL, you can actually merge some of these assets and create a composite looking data asset, which kind of hides the underlying data assets that actually composes. So you can say, this is my order API, but the order is actually consists of the product, the order, the sales order, and many other items. So you can consolidate all these things into one asset and then say, this is my order. That's it. So the consumer doesn't need to understand how your organization's internal data products are going to work. So that's one of the benefits of this using the GraphQL. The second benefit is now you can see, rather than you having to create more and more different experience layer, you just provide one experience layer for all the different channels. And the consumer decides what they want to get based on their requirements. So from your point of view, you write it once and you are done. And it's up to the consumers to understand and decide which attribute from which object, for example, that need to be pulled into their use case. Any questions up to this point?
So my philosophy point, like how it was propagated was like, for customers, you want to have customized back-end to front-end API model. Now with this, you are saying that it's the opposite, right? You have to write your own queries to do that.
Yeah, so it's kind of blurring that particular boundary and saying, rather than you actually maintain per API per consumer, you're actually giving one API, but the good thing is it's going to be owned by the same thing. So the responsibility still lies with the same thing. It's not going to be owned by multiple things. Because when you think about this layer, these are going to be owned by one thing, this is owned by another one, this is owned by another one. But this experience layer, it's usually owned by a single team. So that could be your like a digital team, for example. So still within the same team, so the control is there. And I would say, like, if you want to control who access what, there are different controls you can build into the GraphQL. So you can decide who can see which details as well, because that's part of the authorization. So during the authorization, you can say, like, I want the partners to see these details, but not access the shipment details, for example. So you can pick and choose and then do that particular details as well. So the technology that we use for this one is called the Anypoint DataGraph from MuleSoft implementation point of view, and that provides the unification of the APIs. So rather than you having like multiple data services, you just provide a single powerful data service. The best thing is, like, you don't have to write any code. It's all based on configurations and clicks. So that's the benefit that you get. And the second point we already discussed, and it's very easy to start. And it's really easy to maintain because it's completely managed on the cloud, for example. So this is the two set of details that I was just talking to you about. So you have this order API, and then you have the sales API. If you think about the sales API, sales is actually talking about the orders as well. So why do you actually have to have two different APIs and two different data objects? Just representing the order in the order domain and the sales order in the sales domain. The consumer does not need to know about this distinction. From consumer's point of view, this is just an order. So what you can do, you can actually, when it presents back to the consumer, you can merge these two together and then present as a unified order object. So that's the benefit that you get from here. And the second thing is, you have the order, and then you have the shipment details. So shipment details and the order has a foreign key relationship, right? Like order ID from the shipment is actually the primary key for the order. So now this is actually called a link because that's a linkage between the two data elements. So these are like the constructs of the data graph. So this is just an example of that use case. So now we are jumping into the technical details. So this is actually this slide and the next slide is the details that we spoke about during the February meetup that said we are going to have these features coming in. So the good news is those features are actually here. So we already have the mutations, we have the CLI support, and then the practice rule sets are there, and the GraphQL federation, which I will actually touch base in the demo, and the GraphQL APIs in the Exchange, which is for the socializing aspect as well as for hosting, and you can actually use the GraphQL console in Exchange as well. So things on the left-hand side we have already delivered, and things on the right, they are on the roadmap. So we don't have a release date yet, except that it's for the first half of 2024. So there are more changes coming, more features coming in, and there are some other features that already been added in the last 6 months. So DataGraph, how it works and what it supports. So like I mentioned, the DataGraph is actually based on the GraphQL. How many of you actually have heard the GraphQL before? So GraphQL is actually, if I'm not mistaken, is initiated by Facebook because they wanted to have this dumb pipes and smart endpoints. So that's the actual concept behind, or the starting point behind that particular details. So rather than the API having that knowledge of how everything is being used, how it's to whom I'm going to serve, that responsibility is being shifted back to the left-hand side or the consumer. So the consumer decides what I want, when I want, and what do I to do with that particular data set. So that's why that responsibility is shifted to the left-hand side. So the endpoint is actually smart, the pipe is really dumb. Because pipe is just pulling the data set and then giving it back. So that's the idea. This kind of knowledge is, or this particular pattern from GraphQL is actually not something new. We had OData in the past, which was supported by Red Hat, Microsoft, and Salesforce, predominantly from technology perspective. So OData provided something similar. So what's the difference between OData and the GraphQL? So OData, before I tell, anyone know what this is? So OData, it actually used to run on top of JSON, but it has its own format. So it has, so if you think about SOAP has a certain, like SOAP is based on XML, but in the SOAP method, you have to define a certain structure. So you have to stick to the structure. So you can't deviate from the structure and then expect it to work. So similar thing with OData. You have a structure, you have to say, this is my metadata, and then it has certain operations that it supports, and then it has a certain format that you need to conform to. If you deviate from that one, it's no longer OData. It does not work. So, and then the discovery bit that you have to do in like early on when you set up that the data models. So there was a little bit of overhead using the OData. So that's why people actually start to use GraphQL more than that. So GraphQL simplifies things much easier to consume from the consumer's point of view compared to OData. So this is much easier. You can use the technology to do orchestration across multiple APIs. And the way that we have implemented, we actually support orchestration of the orchestrations. So you build that particular first layer of orchestration layer using the GraphQL, and that's your data graph. And now with the data graph federation feature, you can use the data graph to orchestrate across other data graphs itself. So you can have a mixture of REST APIs as well as other data graph APIs as well. So you can have multi-level of orchestration within the same API orchestration flow. So that's the data graph federation. When you implement the data graph, it actually gives you the ability to run and provide you a unified schema across multiple APIs and other data graph APIs. So the output is actually a unified schema, which actually deployed as single SaaS endpoint. That's where the simplification of the operation aspect comes in, because we take care of your unification of the schema and we deploy it on our platform, and you just get an endpoint. So you don't have to think about where it is running, how you maintain it, how you scale it, or anything like that. So things are pretty easy from your consumer's point of view. From the capability point of view, we support RAML, OS, as well as GraphQL for the orchestration. And you can actually have 250 different APIs for a given unified schema. And you can have up to 16,000 fields per unified schema. So that's a lot of fields. And you can actually go to up to 100 nested levels in the query depth. So this is actually, think about this. So you have the custom object. Within the custom object, you can have the first name, last name, and the address. And the address can be another object. So you can have object within object within object, because it's all JSON, right? So you can actually go like 100 levels like that. And what we provide from the timeout perspective is actually 30 seconds timeout. So if you think about the timeout for a GraphQL orchestration, there are two timeouts. One for the request coming into DLB and then doing the orchestration. And then the second thing is from the GraphQL endpoint into your backend, right? So there are two timeouts that's in the picture. So for every single request coming in from you as a consumer into DataGraph endpoint, this is the 30 seconds timeout. But how much time will it take to orchestrate and with the backend? So it's at least 10 seconds per your API in the backend. So it used to be 5 seconds, but we now support 10 seconds. So why that matters? So most of these orchestration are actually going to happen in parallel. So you get a request to the GraphQL, and the GraphQL is actually going to orchestrate across 5 APIs. And imagine all these 5 APIs has 100 different fields or 150. So we are talking about 150 into 5, 750, right? So now you have to actually accumulate and create a combined object of probably like 750 elements in there, which is going to be a lot of attributes. So it will take more than 10 seconds. So this is why that 30 seconds is there. Hopefully that makes sense. So this is how that network architecture looks like. So the GraphQL is fully managed. It's deployed within your VPC. And this is your control plane. It's coming into like a deployed inside here. And then you have the DLB. And then you can actually even access through the shared load balancer as well. So you guys are all, most of you actually from MuleSoft background, so I don't have to explain what the DLB and what the SLB is.
So GraphQL is sitting in front of the DLB.
It's GraphQL is sitting behind the DLB. So this is your DLB. And you can actually access that GraphQL endpoint through your DLB because it's part of your VPC itself. But every single VPC can access through the shared load balancer. So the same mechanism actually works in this case as well. So if you have cut this shared load balancer path, the request comes from the consumer, hits the public internet, comes to your DLB, access the DataGraph endpoint, and then the DataGraph will start like orchestrating to API 1, 2, 3, and
it's depend on input data, like where exactly he has to navigate the request. So it's depend on the input data, where exactly he has to navigate that request API.
Correct. Yeah, because that logic is actually within the part that you created the unified schema.
Mm-hmm.
If let's say you ask for the customer, and with the customer you actually ask, I want to get the customer by customer ID 1,
mm-hmm.
and I want to get all the orders. So these are obviously 2 or 3 different APIs. So the DataGraph understands that relationship that you created, because to create the unified schema, you have to import all the schemas and then you create the relationship. So once it gets here, it knows I need to call the customer API, I need to call the loyalty API, I need to call the order API. So it's going to call all these APIs, take all the responses, and then orchestrate and create the unified schema based on the logic that you wrote, and then provide the unified response.
Will there any specification like API specification for the data?
It is, yes. So like just like every other API, we actually start the data graph from the specification itself. So you first import all these 3 different or X number of APIs into the exchange, and from there you can say, I want this API to be available for the orchestration. So that's like a collaboration. So from there you can actually start creating the graph. So it will be part of the demo.
If we have universal API gateway, then it is still from.
You mean the Flex Gateway?
Yeah, Flex gateway.
So you will be able to use the Flex Gateway to front it, but it really depends on where you host that Flex Gateway, because right the second we can't host the Flex Gateway inside the VPC in the Cloud Hub. So you can have a Flex Gateway here, which is actually front in the DLB. But the problem is it's gonna go through 2 API gateways, because this one has a built-in API gateway in there, because we are gonna give you the ability to apply certain policies. So I'm gonna touch on that.
Just one question. Is in the previous slide?
Yep.
Are the API 1 and API 2 are part of the orchestration from the graph?
Yes. So from here, API 1 and 2 are part of the orchestration itself.
Okay, so those are 2 not different process APIs.
They are 2, like they could be different process APIs, system APIs in there, but usually, of course, because like we always ask you to provide like go through the 3-layer architecture for data isolation.
Yeah.
It will be the process API. So this is PAPI 1, PAPI 2, and PAPI 3.
And we can leverage API manager for the policy.
Yes. So for these APIs, you mean for them you can use the policies. For this, it's a slightly different, but still like the policies are there. So from how you're using it and how the technology works, think about the data graph as actually 2 different operations. So anything that you query is actually the query, like it's simply as like a get operation. When you orchestrated your unified schema across multiple APIs, I would assume none of these APIs are only going to have get, right? They will have get like a post, put, patch, and all the other operations. So if you think about it, what happens to those operations? They're all going to be combined into mutations. So anything that you had as a gate, that's a query type. And the mutation is actually all the other operations like it's mentioned here. So that's the easiest way to think about what the query type and the mutation is. Then level 1, nested types. So level 1 object. In the example of customer, you have the customer object, and inside the customer object, you have the address, which is another object. Within the address object, you can have the address line 1, address line 2, postcode, and so on. So the level 1 object is the customer object. The nested type is your address. So you can have the level 1, 2, 3, 4, 5, depending on how you have your data types. And you can have an enum, which means like you have a set number of types or available objects in there, and then union type. So this is about the security. So we do support, from the data graph's point of view, different security profiles. So again, think about the orchestration. There are 2 places that you have to think about the security. First one is when the consumers consume the data graph, and then the second one is data graph orchestrating across the APIs. The policies that we're talking about is actually about these policies, these APIs. So if you have any API secured with basic code, pass-through authentication, client ID, auth2, or in some other custom operation, we can support it. Then thinking about the second type of security, which is the consumer accessing your data graph, we do support 2 policies at the moment. So that's based on client ID enforcement and SLA-based rate linkage. So these are the 2 policies that we support at the moment. So and there are more security policies coming in, for example, like O2, but they are currently on the roadmap. They will be delivered in the future, but I can't give you a timeline, unfortunately. In terms of the scaling and performance, you have to understand orchestration across multiple APIs up to 100 is going to take a lot of performance to account. But surprisingly, you can get quite a lot of performance out of the Anypoint DataGraph. So for example, some of the examples I have seen, with 0.2 Vico, you can actually get about 150 TPS. So that's a lot of performance with like a smaller size from the deployment point of view. And you can actually increase these different levels using different packages. For example, by default, DataGraph supports 1 million annual API calls and 150 concurrency. And this particular numbers is actually per unified schema per environment. So if you have multiple environment, you can have X number of this number. This is about the demo, so we are just going to go there. And in the demo, what we are going to have is a federated use case. So we are going to have a GraphQL orchestrating across a REST API as well as another GraphQL and producing the results. So it's going to have the merge types as well as the mean types. So any questions before we jump in there?
Cloud Hub 2.0, does it support DataGraph?
Not yet, but it's on the roadmap.
Okay.
So at the moment, we only support the Cloud Hub one, right?
Okay.
I hope the voice is.
That's function of these APIs. So the
And for the next steps, so if you already have an Anypoint account, unfortunately, you will not be able to get this particular like a feature, but you can sign up for a new free account and then give a try with the new account. So this side is just to sign up for a free Anypoint account. The right-hand side for the tutorials on how to like create a simple DeFi API, just like what we saw. So these are the two QR codes in case if you need to scan, or this is just like a Google link that you can find it. So the next one is actually going to be done by Raquel.
So I know we're only 1 minute away from when we're supposed to finish, and I know you all want to get home. So I'm only going to do just one slide really quickly because we're going to do the trivia. So who's MuleSoft certified? I have my associate certification. Awesome. Who's done any of our courses with an instructor-led learning? Now they call it expert-led. Anybody? The rest of you done self-paced? Is that the way you've learned? Okay, and then on the job, I guess. So all of our training now lives on Trailhead Academy. Used to be on the MuleSoft training website, but actually you can still access our online learning for MuleSoft there, but for all the expert-led courses, it's now through Trailhead Academy. Who knew that there are now 7 MuleSoft certifications? Jose?
Is the hyper automation one the latest one?
Yes, that is the latest one. There's also Catalyst, I think that was recent release, and then the associate one, I think late last year. So yeah, there's now 7 certifications, and I think maybe by the end of the year there might be an 8th one. We'll see. Do any of you have Salesforce certifications, credentials? Yay! Yeah, this is pretty cool. If you hop onto our website, Trailhead Academy, you can go to the credentials page and you can filter through the roles, and then it'll show you like a path or the different certs that you can get for that particular role. So you might want to check that out. There's our website there, trailhead.salesforce.com. And lastly, that was it. So super quick. Let's do the trivia. Yay! I'll just get you all again.